Welcome to this mini project where you're going to get some experience working with Systems Manager. Now, to get started, you need to make sure that you're logged in to an AWS account with admin permissions. If you're using one of my courses, then you can use the I am admin identity of the general AWS account, so the management account of the organization. If you're not using any of my courses, then just use a dedicated training account and make sure that you're logged in with an admin identity. As always, make sure you have the Northern Virginia region selected. Now, this mini project might work with other AWS regions, but US-East-1 or Northern Virginia is the only one that it's been tested with. Now, to get started, we're going to be creating two EC2 instances that we're going to be using with Systems Manager. Before we do that, we need to give these EC2 instances permissions to interact with the Systems Manager product, and for that we need to create an IAM role. So to do that, click in the search box at the top and type IAM, and then open the IAM console in a new tab. Once you've done that, move to that tab. You can ignore any notifications about console updates or any other security alerts. Just go ahead and click on Roles and then click on Create Role. Now, the role is going to be used by an AWS service because we're creating an EC2 instance role. So at the bottom here, go ahead and select EC2 and then move on to the next step. Now, we're going to assign an AWS managed policy to this role. So in this search box at the top, go ahead and enter Amazon SSM Managed Instance Core, and then select this particular managed policy and move on to the next step. For the role name, go ahead and enter demo-ssm-role. Everything else looks good, so we can scroll down to the bottom and click on Create Role. Once that role's created, then we can move to the EC2 console and create those instances. So click in the search box and type EC2 and then open that in a new tab. Now, we're going to be creating two EC2 instances. One's going to be using Amazon Linux and the other is going to be using Ubuntu. So click on Instances Running and then click on Launch Instances. First, we'll create the Ubuntu instance. So under Name, type Ubuntu. Then scroll down and under Applications and OS Images, select Ubuntu. And then in the drop-down, we're going to change it to Ubuntu Server 20.04 LTS. So this should be listed as free tier eligible. So select that. We're not using the latest version of this AMI because it has a few issues, so we're going to use the previous LTS version. Now, under Architecture, make sure that it's set to 64-bit x86 and then scroll down, and for instance type, you need to pick either T2.micro or T3.micro, whichever is free tier eligible. In my case, it's T2.micro, so I'll select that. And then under key pair login, this is where you'd normally select a key pair to use to access the EC2 instance, but because we're using Systems Manager, we don't need a key pair. So click in this box and select Proceed without a key pair, not recommended. Scroll down further still, and under Network Settings, click on Edit. Make sure the default VPC is selected in the VPC dropdown. It should say default, and the CIDR should be 172.31.0.0/16. We don't need to pick a specific subnet for this instance to go in, but we do need to make sure that it has a public IP address, so make sure that auto-assign public IP is set to enable. Now, under Security Group, we're going to create a new security group, and what I want you to do is to note down the name of this security group. So yours might say something different. It might be launch-wizard-1 or another number at the end, but we're going to need to clean this up at the end of this mini project. So just make sure you note down whatever the security group name is in this box. Once you've done that, scroll down all the way down to the bottom and expand Advanced Details. Locate IAM Instance Profile, click in this drop-down and select the IAM role that you created in the previous step, which should be demo-ssm-role. Once you've done that, everything else looks good, and you can click on Launch Instance to launch this Ubuntu EC2 instance. Now, we're going to be repeating that same process to launch another instance, this time using Amazon Linux 2. So click on Instances again, and then go to Launch Instances. For name, put AL2, scroll down, select Amazon Linux, and make sure that you pick Amazon Linux 2 AMI. Don't pick anything more recent. In my case, there's Amazon Linux 2023 AMI. I'm not going to pick that. We're going to pick Amazon Linux 2 AMI HVM SSD volume type. So select that and make sure the architecture is set to 64-bit x86. And then again, under instance type, make sure it's set to T2 or T3.micro, whichever is listed as free tier eligible. Once again, we don't need a key pair because we'll be using Systems Manager, so click in this box and select Proceed without a key pair. Under Network Settings, click on Edit. Again, select the default VPC. We don't need to select a subnet, but do make sure that Enable is selected under Auto Assign Public IP. Now, under the security groups here, we're going to select an existing security group and make sure you pick the one that you created in the previous step. In my case, this was Launch Wizard 2. This is one of the reasons I told you to note this down in the previous step. If we reuse the same security group, then it's one less thing to clear up at the end. So in my case, I've picked Launch Wizard 2. You should select the security group whose name you noted down in the previous step. Once again, scroll down to the bottom, expand Advanced Details, and under IAM Instance Profile, click in the drop-down and select the IAM role that you created at the start of this mini project, so demo-ssm-role. And once you've done that, everything else looks good, you can go ahead and click on Launch Instance. Now once that's started launching, click on Instances, and you'll need to wait until both of these instances are in a running state, and for status checks you see 2 out of 2 checks. So go ahead and pause the video, wait for both of these to show as running and 2 out of 2 to show under status check, and then you're good to continue. Okay, so now both of these instances are in a running state, and we see 2 out of 2 status checks for each of the instances. Now at this point, both of these instances are in a public subnet and have a public IP version 4 address associated with them. In addition, both of them have an EC2 instance role which gives them permission to interact with Systems Manager. And they also both have the Systems Manager agent installed on those instances, and this is because the AMIs that we used include the Systems Manager agent. So to see that, if we click in the search box at the top and start typing Systems Manager, and then right-click on Systems Manager and open that in a new tab, once this is loaded, on the menu on the left, scroll down and click on Fleet Manager. And Fleet Manager, if everything's configured correctly, should show both of your running EC2 instances, together with various bits of information such as node name, platform, operating system, and so on. Now if we go ahead and click on one of these nodes, and we're going to pick the Ubuntu node, so go ahead and click on it, you'll be able to see additional information. So the node ID, the platform, the node type, the source type, in this case EC2 instance, the operating system, the version of the SSM agent, and then the IP address of the instance. In this case, it's the internal IP address. Now we can also go ahead and click on File System and see a file system overview of this EC2 instance. So this gives us internal operating system visibility. So we can interact with the file system without having to connect to the instance. So for example, if I select this dev folder, then I can click on Actions and perform various file system manipulations, such as local file transfers, viewing a file, deleting, or renaming a file. Now I can also use Systems Manager to perform software updates, and we're going to demonstrate that next. But before we do, I want to show you that one of these EC2 instances does in fact require software updates. So I want you to go back to the EC2 tab that you've got open and select the Ubuntu instance, right-click, go to Connect, make sure that Session Manager is selected and then click on Connect. And that will take a few moments, but you'll be connected to a shell on the instance using Session Manager. Now, Session Manager is part of Systems Manager, and we can connect to this because the instance has access to the Systems Manager endpoint, and we've given it permissions using the instance role. Now, what I want to do to demonstrate that this instance does in fact require software updates is to run this command. So sudo space apt space and then update, and then a space, and then double ampersand, and then a space, and then sudo space apt space upgrade. And once you've typed all of that, go ahead and press enter. Initially, it's going to update its repositories on this instance, so essentially download a list of the latest packages available for this operating system, and once that's completed, it's going to show you any packages that require updates. In this case, you'll see a list of packages that can be upgraded. Now, you could answer yes to perform this update, but we're not going to do that. We're going to press N for no and press enter, because we're going to perform the update using Systems Manager. Now, to do that, go back to the Systems Manager console, click here to go back to the main Systems Manager console, scroll down on the menu on the left and select Patch Manager. Now, we're prompted to create a patch policy, but we're not going to do that. That's beyond the scope of this mini project. What we're going to do is click Start with an overview. Now, initially, you can see various bits of information about your nodes, so Ubuntu and AL2, but because we've not given Systems Manager the opportunity to see what the state of these instances are, we don't have a compliance status, so we're unable to see what patches are on these instances and thus what patches are required. So what we're going to do is go ahead and click on Patch Now, and we could choose to scan the instances or do a scan and install. Now, to keep this mini project as brief as possible, we're going to do both of these in one step. So go ahead and click on Scan and Install. We'll leave the reboot option as reboot if needed. For instances to patch, we'll say patch all instances. And then for patching log storage, we might choose to create logs of the patching process if this were production, but we're going to say don't store logs. We don't need that for this mini project. Once you've set all of those options, scroll to the bottom and click on Patch Now. And that's going to instruct Systems Manager to patch all of the available nodes which it has access to, in this case AL2 and Ubuntu. Now, that's going to take a few minutes to complete. Currently it's shown as pending, and we need this to have been completed before we move on to the next step. So you can keep refreshing your screen, but I want you to pause the video and resume once this changes to operation was successful. After a few minutes, your status should change to success, and you should see operation was successful at the top. Now, what I want to do before we move on is just demonstrate that this has in fact performed a software update. So just go ahead and close down the tab that you have open to Session Manager that you used previously, go back to Instances, click on Instances, select Ubuntu, right click and connect to that instance again using Session Manager. Now, that will take a few moments to connect, but what we're going to do is go ahead and run the exact same command that we did previously to update the software packages. So just as a reminder, that was sudo space apt space update, and then double ampersand, and then sudo space apt space upgrade, and press enter. Now remember, it still needs to perform the same local package list update, so that's what's at the top, but now you should see that there is a lot less packages that require updates because Systems Manager has performed a set of software updates on this instance. Now, it's possible that you still might see a number of other updates, and these are generally optional updates which Systems Manager won't have performed updates on, but this can be configured if you want to go into more detail and configure more advanced options of the Patch Manager functionality of Systems Manager. But we won't do that. This is just an introductory level mini project on Systems Manager. So next I want you to go back to Systems Manager, I want you to click on the association ID for this patch update. We're just going to step through exactly what this has done. So go to versions and then look under document name, and you can see the name of the document is AWS Run Patch Baseline. So this is the name of a configuration document that's been run against our EC2 instances. So Systems Manager documents can be lists of directives or lists of configuration items which can be applied to things that are managed by Systems Manager. In this case, it's a document which performs a patch baseline, so it checks what's running on the instance and, if required, runs additional software updates. I want you to copy the name of this document into your clipboard, and then on the menu on the left, scroll right down to the bottom, and under Shared Resources, click on Documents. Then in the search box, paste in the name of the document which you just copied into your clipboard, which is the name of the document that's used for software updates, and press enter. And you should see a list of results, and we're interested in AWS Run Patch Baseline. So go ahead and click on this document and then go to Content. So documents are JSON or YAML files that contain instructions on what to run on a managed node, in this case an instance. So Amazon provides lots of different managed documents for things like patching an instance or running custom shell scripts, setting tags on instances, configuring port forwarding, and much more. This particular document is something that checks for the operating system type and then runs applicable commands to update the operating system. So if we just scroll down in this document, look for the first main steps entry and then precondition string equals platform type Windows, and this shows the list of commands that are used if the operating system of the instance is Windows. If I scroll down further still, the next one is precondition string equals platform type Linux, and this shows the list of commands that are used for Linux instances. And then scrolling down further still, we've got precondition string equals platform type macOS, and these are the macOS instructions. So this document can be used for Windows, Linux, or macOS managed nodes, and it can help perform software updates on each of these different types of operating systems. Now if we go back to the Systems Manager tab, and instead of clicking on the association ID, let's click on execution ID. And we'll be able to see the individual execution targets that this has been run on. So these are our EC2 instances, and one of these is Ubuntu and one is Amazon Linux 2. So let's go ahead and just pick one at random and click on output. For output, you'll be able to see each of the different main execution steps for this document. So you'll have one for Windows, one for Linux, and one for Mac OS. Now obviously each of these will only be used for the one particular operating system. So if we expand the output of Windows, for example, we'll see that the precondition is not met because this isn't a Windows instance. However, if we look under Patch Linux and then click on Output, we'll be able to see that this did in fact execute because it is a Linux instance. Under Error, we'll be able to see any error outputs. In this case, there were none. So this is an example of a really simple patch process using Systems Manager. What we're going to do next is use Systems Manager to run a command on an EC2 instance. So scroll down on the menu on the left and select Run Command, and then click on Run Command. Now these are all the command documents available, and in this search box I want you to go ahead and type AWS-run shell script and press enter. So check the box next to AWS-run shell script and scroll down, and then under command parameters in commands go ahead and enter both of these lines. So what this is going to do is run sudo touch to create a file, and then it's going to call the file /hello_from_systems_manager. So this is going to create a file on a Linux instance with this name. And then this command, so sudo space useradd -c Jeff Bezos space J Bezos is going to add a user within our Linux operating system called J Bezos. Scroll down and we need to select the target that we're going to run this against. So select Choose Instances Manually, and we're going to click this box to select both EC2 instances. So this is going to run this command on both of our available EC2 instances. Then scroll down, and under Output Options, we're going to uncheck Enable an S3 bucket because we don't want any output logs of what we're about to run. Scroll down to the bottom and click on Run, and this is going to run this command document on our EC2 instances, which will have the effect of running a shell script which we've provided, which will create that file and create a Linux user. Now this does take a few moments to run. Keep clicking on Refresh. We'll see immediately overall status is success and detailed status is success. If we go ahead and go back to the EC2 console, go to Instances, pick either of the instances. I'm going to pick Ubuntu, select it, right click, go to Connect, Session Manager and click on Connect. Then once we've connected, if we do an ls space -l space / and press enter, we should see the file that we've just created using Systems Manager. Additionally, if we run a sudo space tail space and then /etc /password, so PASSWD, this should show us a list of any users created on this Linux operating system, and at the bottom here we have the user J Bezos that we just created, again using Systems Manager. So that's an example of how we can use run command to execute commands or scripts on any managed instances. Next, what I want to do is go back to Systems Manager, scroll down on the menu on the left and click on Inventory, and then scroll down and click here to enable inventory on all instances. Then if we scroll down and just click on one of these instances and then go to the Inventory tab, we'll be able to see additional information that's been gathered from these EC2 instances using the inventory feature of Systems Manager. So we can see all of the applications installed on the EC2 instance. If we click here and change it to network, we'll be able to get a detailed overview of networking on this EC2 instance. We can go to instance detailed information, and this will give us access to detailed information about the instance, such as the exact CPU model, the number of CPUs and CPU cores, the CPU speed, any hyperthreading enabled, and other relevant information. So inventory is a really useful feature to gather additional detailed information on your EC2 instances. And at this point, that's everything I wanted to cover in this mini project. It's just been a brief walkthrough of the types of functionality delivered by Systems Manager. At this point, all that remains is to clean up all of the resources we've created during this mini project. So to do that, go back to the EC2 console and go to Instances. Select both of the instances, go to Instance State and then Terminate Instance. Make sure you're only terminating instances you created within this mini project and then confirm that termination. Then on the menu on the left, scroll down, go to Security Groups and delete the security group which you created at the start of this mini project. Remember, I asked you to note down the name, in my case, Launch Wizard 2. So select it, go to Actions, scroll down, delete security groups. Make sure that it is the security group that you created, and you'll need to wait until both of those EC2 instances have finished terminating. In my case, I got the error suggesting they haven't, so let's go back to Instances. We can see that one has terminated and the other has just terminated. So now we should be good. Go back to security groups. I'll just do a refresh. Select the security group I created at the start of the mini project. Go to Actions and then delete security groups and confirm that deletion. Then we need to go back to the IAM console. Go to Roles. Type demo-ssm. Find the role you created at the start of this mini project. Select it. Go to Delete. And then confirm that deletion. And at this point, that's everything that you need to do to clean up the account. Any of the instances which are managed under SSM will automatically be removed once they're detected as being terminated, so we don't need to do anything within the Systems Manager console. That's everything that you need to do in this mini project. So I hope it was enjoyable, and I look forward to you joining me soon in another exciting mini project.